In this example problem, we're asked to calculate the boiling point and freezing point of a 25% by mass antifreeze solution. An antifreeze contains CH2OH, CH2OH. We have a Kb of 0.51 degrees Celsius per mole and a Kf of 1.86 degrees Celsius per mole. In each of these equations, we need to determine what the molality is. So the molality of this solution is going to be moles of C2H6O2, which is our antifreeze, divided by kilograms of water. So we have moles of solute per kilograms of solution. Okay, so it's a 25% by mass antifreeze, so that means that we're going to have 25 grams of C2H6O2, and we're going to have 100 grams of that solution. So that means the grams of our water has to be 100 minus 25, or 75 grams. We can do a conversion then. We know that 1 mole of C2H6O2 is going to be 62.1 grams. And then we also know that 1,000 grams of water is going to be 1 kilogram. So that gets rid of our grams of our antifreeze, our grams of our water, and we're left with moles per kilogram. So our molality is going to be 5.37 moles per kilogram. So in terms of each of these, we can say that the delta TB is going to equal Kb times m. And we also know that the delta Tf is going to equal Kf times m. So all we need to do here is put in our values that we've been given in this particular problem. The Kb is going to be 0.51 degrees Celsius per mole, and our molarity we know is 5.37 mole. That gets rid of these two guys, and our change in temperature in terms of the boiling point is going to be 2.7 degrees Celsius. We can do the same thing for our change in the freezing temperature. We have 1.86 degrees Celsius per mole times a molarity of 5.37, or sorry, a molality of 5.37, and that's going to give us a value of 10 degrees Celsius. So we need, and we weren't given here the boiling point or the freezing point of water, but we know that for pure water, the boiling point is going to be 100 degrees Celsius, and the freezing point is 0 degrees Celsius. Remember when we look at our colligative properties, we have a boiling point elevation and a freezing point depression. So when we look at this change in temperature, we need to add the value, which in this case is 2.7 degrees Celsius, to the 100 degrees Celsius. So our new boiling point is going to be 102.7 degrees Celsius, and our new freezing point we need to subtract, and that's going to be now minus 10 degrees Celsius. So remember, we have boiling point elevation and freezing point depression. So here's our new boiling point, and this is our new freezing point with the antifreeze solution added to the pure water.